Volume.
Volume is the quantity of three-dimensional space enclosed by some closed boundary, for example, the space that a substance or shape occupies or contains. Volume is often quantified numerically using the SI-derived unit, the cubic meter. The volume of a container is generally understood to be the capacity of the container, i.e., the amount of fluid that the container could hold, rather than the amount of space the container itself displaces. Three-dimensional mathematical shapes are also assigned volumes. Volumes of some simple shapes, such as regular, straight-edged, and circular shapes can be easily calculated using arithmetic formulas. The volumes of more complicated shapes can be calculated by integral calculus if a formula exists for the shape's boundary. One-dimensional figures, such as lines, and two-dimensional shapes, such as squares, are assigned zero volume in the three-dimensional space. The volume of a solid, whether regularly or irregularly shaped, can be determined by fluid displacement. Displacement of liquid can also be used to determine the volume of a gas. The combined volume of two substances is usually greater than the volume of one of the substances. However, sometimes one substance dissolves in the other and the combined volume is not additive. In differential geometry, volume is expressed by means of the volume form, and is an important global Riemannian invariant. In thermodynamics, volume is a fundamental parameter, and is a conjugate variable to pressure.
Units.
Any unit of length gives a corresponding unit of volume, namely the volume of a cube whose side is the given length. For example, a cubic centimeter, cm3, would be the volume of a cube whose sides are 1 centimeter, in length. In the International System of Units, SI, the standard unit of volume is the cubic meter, m3. The metric system also includes the liter, L, as a unit of volume, where 1 liter is the volume of a 10 centimeter cube. Thus, small amounts of liquid are often measured in milliliters, where various other traditional units of volume are also in use, including the cubic inch, the cubic foot, the cubic mile, the teaspoon, the tablespoon, the fluid ounce, the fluid dram, the gill, the pint, the quart, the gallon, the minim, the barrel, the cord, the peck, the bushel, and the hogshead.
Related terms.
Volume and capacity are thus sometimes distinguished, with capacity being used for how much a container can hold, with contents measured commonly in liters or its derived units, and volume being how much space an object displaces, commonly measured in cubic meters or its derived units. Volume and capacity are also distinguished in capacity management, where capacity is defined as volume over a specified time period. However, in this context the term volume may be more loosely interpreted to mean quantity. The density of an object is defined as mass per unit volume. The inverse of density is specific volume, which is defined as volume divided by mass. Specific volume is a concept important in thermodynamics where the volume of a working fluid is often an important parameter of a system being studied. The volumetric flow rate in fluid dynamics is the volume of fluid which passes through a given surface per unit time, for example cubic meters per second.
Volume formulas. Volume ratios for a cone, sphere and cylinder of the same radius and height.
The above formulas can be used to show that the volumes of the cone, sphere and cylinder of the same radius and height are in the ratio 1:3, as follows. Let the radius be r and the height be h, which is 2r for the sphere, then the volume of cone is. The volume of the sphere is. While the volume of the cylinder is. The discovery of the 2:3 ratio of the volumes of the sphere and cylinder is credited to Archimedes.
Volume formula derivations. Sphere.
The volume of a sphere is the integral of an infinite number of infinitesimally small circular disks of thickness dx. The calculation for the volume of a sphere with center 0 and radius r is as follows. The surface area of the circular disk is. The radius of the circular disks, defined such that the x-axis cuts perpendicularly through them, is where y or z can be taken to represent the radius of a disk at a particular x value. Using y as the disk radius, the volume of the sphere can be calculated as. Now, combining yields. This formula can be derived more quickly using the formula for the sphere's surface area, which is the volume of the sphere consists of layers of infinitesimally thin spherical shells, and the sphere volume is equal to
cone.
The cone is a type of pyramidal shape. The fundamental equation for pyramids, 1/3 times base times altitude, applies to cones as well. However, using calculus, the volume of a cone is the integral of an infinite number of infinitesimally small circular disks of thickness dx. The calculation for the volume of a cone of height h, whose base is centered at 0, 0, 0, with radius r, is as follows. The radius of each circular disk is O of x equals 0 and 0 of x equals h, and varying linearly in between, that is. The surface area of the circular disk is then. The volume of the cone can then be calculated as. And after extraction of the constants. Integrating gives us